Hello chaps and chapettes, we're looking now at thermistors, and following on from our light dependent resistors from before, these are again resistors. By the end of this video you're going to know what thermistors are, you're going to understand how resistance changes with temperature in them, and you should be able to again draw a circuit using a thermistor. Now your challenge task today is to be able to design a thermometer, which should be relatively straightforward once you've actually gone through the video and got the information. But I'll give you some tips as we go. So, first thing you need to know, a thermistor is again, resistor, it's in the name. It's a thermal resistor, thermistor. So it depends on the temperature of the surroundings, or the resistance depends on the temperature of the surroundings. So in this case, well, we have an increase in temperature and the resistance will go down. So the higher the temperature, the higher the current flow. So there we go. Now what you need to do is pause the video, draw the circuit in front of you, draw the components, and understand what it looks like. It's kind of unclear, but again, it is just a box resistor. So it's a box with a funny line on there to indicate it changes with temperature. And we'll look at that in more detail in a second. Right, now this is a thermistor, this thing here. That looks horribly blurry. Let's just try that again. There we go. So this is a thermistor, this thing here. Now on the inside of this, you can imagine that there is a wire. So let me just zoom in on that bit there. There. You can imagine that there is a wire along the top of the surface here. And that is causing some resistance. Now I'm cheating a bit for this one. I've actually just plugged this straight into an ohmmeter, which is basically something that measures resistance directly, where I should really be using a voltmeter and an ammeter to show this to you. But, this thing's very, very sensitive, so I'm just using this to shortcut the whole process. So right now, this is reading 1000 ohms of resistance, which is, okay, fairly straightforward. Now what we're going to do is we're going to heat this up, and we're going to show you what this kind of looks like on the inside. So you can imagine that there's a wire in a zigzag pattern going across this thing right now. And what we're going to do is we're just going to warm this up using my hand. And you can see that straight away the resistance is starting to drop on this thing. So resistance starts to drop. Now, why is the resistance dropping on this one? Well, let's just have a quick check. I'm just going to grab a board marker and I'll show this to you right now. So what's going on with this thermistor? Well, this is the rough thermistor design. You have a ball of stuff, okay? And that can be any sort of heat resistant thing. When I say heat resistant, I mean it's not going to melt at high temperatures, but it will interact with heat. And along this thing, we have a wire which does that sort of pattern, sort of zigzaggy pattern. Okay? There. It's actually really difficult to do for a phone, but there we go. There and there. So when we have the thing cool down, it sort of scrunches itself together, and this is a good way to think about it, because this thing starts to, well, it starts to condense downwards into a new shape. Now when this will heat up, when this heats up, it will start to expand. So this ball bit starts to expand, and that stretches out the wire, and that, roughly speaking, allows the electrons to travel through a bit quicker. So there we go. When this thing heats up, it will start to expand, stretch out the little wire thing on there, and that will reduce the resistance of the device. So there we go. So having a look at that thermistor now, we're going to look at the current and voltage graph there. And you can see we've again got two lines, the green line for high temperature and the red line for low temperature. Now we've gone through the structure and how it changes with temperature, and this is the result. The resistance is going to change depending on what heat conditions you put your thermistor in. So there we go, these lovely little curved lines instead of the straight lines before, for various reasons. Right, what you need to do now is go ahead, sketch out the voltage current graph, see if you need ask any questions, have a go at some exam questions, but really try and design a thermometer using a thermistor. Things you need to think about. Think about what readings you're actually going to get from this one, and then also think about how you can interpret that to get temperatures out. Think back into previous topics about how to make thermometers in general and how to calibrate them, and then apply that to using a thermistor. I'll catch you in the next video.